Good morning, good afternoon, or good evening, depending upon where you live around the world. If you can put up with the whirring in the background from my noisy computer, this is just a quick update of where I am at the moment with the hub development idea. I did make a comment which is possibly quite true. I may not even do this project or use this particular hub design. However, the more I work on it, the more I like the idea of its flexibility. If I change something and I were using the star plate type design, I'd have to get a new set cut to work with the new or altered design. This approach, however, is design independent, and therefore it can be adapted, changed, altered, whatever, for any design. So long as the items can fit inside the strut itself without causing any issues, then it can be used for all the different designs that I'm not even thinking about. And more importantly, it does, I think, have the ability to become a very strong connection for that paranoid inducing point of the dome that I over concentrate on, and that's where the bottom triangle and the top actually join. Whereas in the star plate type thing, the Viking domes, I think it is, that make them, and others, while theirs would also be very strong, like I just said, if I alter something to meet my God knows what requirement, then I can change at a whim almost to meet that design with this approach. Yay! That's got to be a double thumbs up for carrying on and pursuing the investigation, and we'll call it that. In front of us there are three sets, you could say. I have been a bit lazy and not deleted these ones. Actually, I'll delete some of them there so you can perhaps better understand where I'm coming from. But I have three sets dependent upon which approach I want to pursue. Screw, tab, whoops, there's another one hidden in there. Screw, tab, or the lower assembly using a threaded rod and pipe. In some instances, you'll use this in both positions, upper and lower. This one also can be used in the upper and lower positions. I've yet to show that. And this one, the screws generally will only be used in the upper assembly because of the way they insert into the struts through the hub. You have to have, as I will show here, you have to have the ability to thread the screws in. And if you look carefully here, if I was looking along the axis of the screw, I can, in theory, have all of these screws inserted once the struts and hubs have already been bolted together utilizing the lower assembly method. I have also shown, actually I'll just unhide, I have also shown alternate methods for the insertion, not methods but options for insertion of the threaded rod. I've just shown them in the center of the strut in this case, just as a mock-up, where we can have a 12mm rod, a 10, or an 8mm rod. 8 would still be pretty darn good, but it's for the lighter domes. And and it may be that you could use this in an upper and a lower situation, where the lower one could be the heavier grade of threaded rod, because that is the one that's going to do the majority of the work, in my non-engineering opinion, and the lighter one at the top. So it could be a 12 and an 8, or a 10 and an 8, whatever. But I looked at it and I thought, rather than trying to, as one of my options, thread this pipe so that the threaded rod that goes through horizontally can thread through the pipe, and I thought that is a pretty good idea actually. Still might work. I thought, why can't you just insert a nut? If you can get a nut in there, and you can. So I thought, well, the nut's already engineered. I don't have to prove my threading ability to the local council, and the council could see, if I needed to permit for this, they could see that the threaded rod and the nut are engineering. Put this way, I'd probably have to go to an engineer first if I were going to submit this sort of design to the council. If I had to thread this, I'd have to prove my capabilities as an engineer for the threading of it. Stupid, I know, but there you go. So I thought, well, a nut in place might be prudent. And then I was looking at this and I was going, why can't I have half a piece of pipe, allowing for a little bit more fiddle room in the hole for the nut? Still looks okay. This looks better. This looks okay. Because these half circles are also one of the choices we may look at for the interface in the some of the models. Sorry for the zooming in and out, but whoops, we will hide that and that, because some of the interfaces, I've grouped them together so when I was rotating it, anyway, some of the interfaces are half round of the pipes, so yay for that. And ditto for these. Some of them, oops, not there, haven't included it, but they are half round for the interface for the screws. I've probably deleted it, oh dear. And I can now progress a little bit further with this this development. I think the next thing may have to be to show, in fact, if you just wait there, I think I've prepared something earlier. I'll just go check. Just wait there a minute. Yes indeed, I have got this. This is showing the heavier strut, or rather deeper strut, 140 millimeters, and it's easy to see the use of the what would normally be, I would call the lower assembly, but the threaded rod and pipe type connector, so that it can be lowered to its lowest practical extent at this point here, because you don't, of course, and raised up to a reasonable height here. Perhaps that's all you need. You don't need the strap. I just included them because they were easy to include for consideration, but you could forego these straps and just have these two connectors. A 200 deep timber, that'll be what's 140, that'll be 190 mil deep, so it's a X 200. Means that all I need to do there is to cut the pipe at a longer length and lower the pipe and rod, and therefore I've got the next stage up of connector. They could be 12 mil, or the rods could be 12 mil, or if it was of such demand, 16 millimeter. The strength generated by that connector pretty high and combined with the upper one. The other option, which I haven't explored yet, is when we double up in width. And this system still meets all the requirements. All I need to do is extend the length of the pipe to accommodate the extra width of the strut. That is what I'm considering for my own dome on the lower part of the dome, the leg part, my paranoia inducing part of the dome design. Whereas I have a thicker, not deeper, but thicker timber, and all I needed to do was to extend the pipe length, and I have got exactly the same setup ready at hand to adapt to that. Sorry for the emphasis, but adapt to that. And it means I don't have to alter a design for the laser cutter if I were using the star plate type of fixing. That is still, I think, one of the more elegant hub designs that is relatively straightforward. Viking domes, I hope it's Viking domes, I'm giving them a bit of a rap anyway. They look really, really nice. And if I wasn't so invested in this type, invested is not probably the appropriate word, but if I haven't gone down the track and I can see the reasoning for what I want to do of this, the star plate would probably be my preferred option, just because of its aesthetics. I like the idea of being able to put one top and bottom to equalise the stresses, and as they say in their bit of the explanation, it's more than twice as strong as just having the bottom one, which would be their norm. I like it a lot. But as I said, if in my infinite stupidity I alter something, I can change this on the fly. I can literally out in the workshop alter something and it adapt for me. Also, if I make a second dome, God, I haven't even made the first one yet, then if I alter something in that, I can alter this. But if I had the star plates type of thing, I'd have to... Starplate being a brand name, I apologise, but Viking domes are, as I say, are absolutely brilliant. I really, really like them, but they don't apply to my situation. Therefore, I'm forced to make my dome suit the plate, whereas this adapts to any alterations and or cock-ups. If I make a mistake, innocently, of course, I can likely adapt this much easier than having something, trying to make something alter on a one of the plate type connectors. So you can see perhaps the inertia behind this approach. Of course, we've got the companies like, and gosh, I don't know whether it's pronounced it, but Eltbar, that I've seen where they've got the manufactured hubs. That is also a very, very attractive approach to, or look, so the aesthetics of that is, very, very nice. But the necessity to have the threaded rods, this is the equivalent, or could be classed as, they would work in conjunction with that approach. But to get those manufactured wouldn't be a simple process, or it won't adapt if you make a mistake. So again, I think this approach, be it a combination of lower assembly type threaded rod and pipe, or tab or screw, has more flexibility and still has the capability of the others, and it needn't look too ugly. From the underside, you could put a cap on here, Because that's what I'm thinking. If there's a cap over this that can mount the like lighting, a little LED light or some such, and these don't look unattractive as if that's what you're seeing from underneath. I still think this is a very viable option for all those different requirements that a dome builder would have. Relatively easy to cut. Okay, you could cut it with a grinder and a template if you wanted it nice and square. Can be sanded on a bench sander or even a handheld sander, but I don't know how easy that would be. This is the metal, remember, and probably better if it was cut with a chop saw, probably, or a small bandsaw type thing. So that's starting to get a little bit more demanding. The average workshop won't have one of those, but I think an engineering shop should be able to cut them to your specific requirements relatively easy, or you can just persevere and do it with your hand grinder. Don't know whether I'd recommend it, but there you go. There's actually not all that many of them, so perhaps you could make a template up or a guide, run around to the edge with your grinder, and then yeah, because there's not that many. Ditto for these pipes, they're just going to be the same or close to the same length, whether you have it the thickness of the strut itself, in this case 45, could be 50, could be not, whatever, and then the interface pieces, instead of these solid blocks, if we have the pipe. Also, there's a suggestion that these interface blocks can be a slice of the pipe, so that the radius, even though you'd be putting the outside radius on the inside, you could get a interface piece to replace this, and it's just an offcut of the pipe. Again, economy and ability to do it in the home workshop is probably easier than trying to make one of these interface blocks, to be fair. If we've already got a curve, i.e. the outside diameter of the pipe, or even using it as I actually have done a section of pipe where it was 90 millimeters, so the outside well, the radius was 90 millimeters, no, the diameter was, anyway, and even though it's had a bit tighter radius than the inside of this, I thought, oh, this actually for the effort not too bad. And I thought, no, hang on, why get another pipe at all when you probably will have offcuts of this, or air quotes prototypes, to the average person, mistakes. You have a pipe where you could cut down the length of it, and that gives you the curved interface of the here, and then flat the inside off on a on your bench sander. Now that will be so easy to do. I thought, oh. So I have, for now, in my mind, forgone this separate item and going for a strip of pipe adapted ever so slightly to that for the use. Also, it's a little bit thinner in this area here, so it makes the clutteredness here just that little bit less. Anyway, there we go. That was going to be a 5-minute update, now gone to almost 20 minutes. Have I ever been accused of talking too much? Well, I have, trust me. Anyway, there we go. You might pick up in my voice that I'm very positive about what we're doing at the moment, and well, I'm positive in the sense that if there's a way forward that doesn't seem to have a block coming up, then of course I'm going to be happy. So might have to go grab a section of pipe and see whether all my yik-yakking and theorising is practical. Because, as Einstein said, in theory, practice and theory are the same. In practice, it's not. I think I might have butchered that one, but you get the point, hopefully. And with that, 20 minutes. I'll see you later now. Bye.